and welcome to another episode of FooBar. In today's episode, we are learning about EC2s. If you want to know more about serverless, cloud computing, or software engineer practices in general, subscribe to my channel in the red button below. I post videos on Tuesdays and on Thursdays. So let's get started! So this is another episode on the series Get Certified with me. I have done many episodes where I talk about my certification process, how I did the cloud practitioner, and which certification I will be studying next. I decided I will be taking the developer associate certification, and it's the most serverless certification of all, we already find out. So if you want to study for that certification, you can find a lot of material in my YouTube channel. But there is some parts of it that are not really covered by my channel. That is the parts of the foundational services like EC2s, VPCs, RDS, and all these things that are not a very big part of the certification, but they are a considerate part. So, because I get distracted very easily, I asked one of my colleagues to help me out. I invite Cobus Bernard, he's a developer advocate in my team, and I asked him if he wants to teach me these EC2 things and if we can record it. So that's the video of today, is me learning how to do all this. So let's get started with it. And welcome, Cobus, to FooBar.
Thanks.
How are you doing today?
Doing well today. I'm actually looking forward to this. I think it's going to be a lot of fun.
Yeah, this is something you have been doing for quite a long time, so you're an expert in these topics.
About 8 or 9 years, so I know a little bit, luckily.
Yeah, so can you tell us a little bit about yourself and what you're up to and where people can find you, so if they want to know more things?
So I've been a developer for, I think, 16 years now or something. It's at that point now where you can't count. You have to count and look at LinkedIn to figure out. Started off with Java and Linux, then switched over to C# and Windows, then went back to Java and Linux, then went back to Windows and C#. And then along the way did a bunch of mobile development, bit of front-end development as well. And then at some point along the lines, I switched over to what people call DevOps nowadays, which is basically a lot of automation, a lot of cloud working. And I built my first AWS system in 2011, I think, or 2010.
Wow.
So quite a while back. It was quite fun. I actually learned why you would want more than one availability zone for your setup because lightning struck one of the availability zones and burnt out everything. Yeah, that was the app stayed up, but that was pure luck because the instances were across 3, but the database wasn't 1, and luckily it wasn't the one that broke. So I will show you today how not to have that problem.
Good, because I think everybody in this channel is super serverless, so people think about high availability comes built in. Nobody worries about availability zones, so I think that's something in this episode you need to worry a little bit about that.
Oh yeah, no, definitely.
So what we are going to do in this series, it's going to be 3 episodes, and what you have planned for us.
So what I'm going to do is I'm going to start off with spinning up an EC2 instance. So EC2 instance is a virtual machine on AWS. And then we're going to try and connect it to an RDS database. So RDS is a managed database service that we have on AWS. And during the course of this, we're going to touch things like what's the firewall settings around them, also known as security groups, what are the options to spin them up, and just explore a little bit of the concepts in the first episode. Then I think in the next one, we're going to go into what IAM roles and permissions are, because we want our instance to be able to use other AWS services. And for that, you need permission, because you can't just do what you want. And then I think, yeah, unfortunately, we have security and it's built into everything very well. So yes, security is very important.
It's very important.
And then once we have all of that running, I'm going to show you that dreaded moment where, oops, I deleted my instance, and why you should use something like auto-scaling groups, and how to make sure that if something like that happens, the instance magically comes back up again.
Cool. So all these series will be linked together in the description box, and they will be releasing bi-weekly basis, so you can go and check them out when they are out. But without further ado, maybe we can start with what is an EC2 instance. I think it's the first time I say that word in this channel.
Cool. I can actually show you, I've got a nice slide for that I can show. So to answer the question of what is an EC2 image, or instance, what you can see on the slide over here is a diagram of what a physical server inside an AWS region would look like. Well, availability zone specifically, rather, let's say, in data center. To clarify that, because I know a lot of people sometimes get confused, is we've got a region. A region consists of 3 availability zones. One availability zone is one or more data center. So inside one of these data centers, inside the AZ, we've got a whole bunch of servers. So this is what we start off with. And then on those servers, we have got our own virtualization software running in the form of a hypervisor. And then we give you a portion of that server or the full server if it's the size of the instance that you are picking. So that's basically just a VM running on there, and that's what an EC2 instance is. So it's either a slice of the machine or you can get the whole machine. And they get quite large. Our largest one is the SAP HANA instances. They have got 24 terabytes of RAM and 256 cores. Yeah.
And what you will use a machine that big for?
So they use them in clusters. They need multiples of those to run big SAP HANA systems, which is, so SAP is an enterprise grade, I want to say not quite a warehousing app, but it's a massive app. So you can run terabyte size workloads on it with real-time analytics in seconds.
Wow.
So, yeah.
That's impressive.
No, so they can be nice and big, or you can go as tiny as our T3 Nanos, which is 384 megs of RAM and I think a quarter CPU. So anything in between those 2 points.
That's cool. So that's our dreaded EC2 that we never spoke about before.
Yeah. So how about we go spin one up?
Yes,
I can show you what that looks like.
Let's do that.
Here we have the AWS console, and we are inside the EC2 section of the console. So if you want to spin up an instance to use, you can click on the launch button over here. And then it's going to take you through a wizard that'll ask you quite a lot of questions. And some of the questions we're going to skip, but we will get to most of the detail at the end of the 3-episode series, effectively. So the first question is, what operating system do you want to launch? So in our case, I'm going to go for Ubuntu because it's the Linux distribution that I've actually used the most. It's just personal preference, but you can pick what you want. You can see over here, we've got SUSE Linux, there's a Red Hat, the Amazon Linux flavor, basically anyone you want, or you can even build up your own AMIs if you want with whatever you want installed on them.
What is an AMI?
So an AMI is an Amazon machine image. So it is a snapshot of the VM that we use then to start up your instance. So there are these pre-built ones that have Ubuntu with, for example, the base packages installed, and then you make a copy of that, and then that's what starts up your VM.
Cool. So you could basically have everything ready, cooked, basically. So when the VM starts, you could just launch whatever you need at the beginning. So you could install your own software or your own packages that you need besides, for example, Ubuntu or Red Hat or whatever as well in there.
There's actually a service called Amazon EC2 Image Builder that you can use to decide what you want installed to build it the whole time. So you can then add additional packages or use a fresher image that's patched or whatever combination you want.
And these operating systems are installed by AWS and they are kept patched or maintained by them to the latest or the most secure version? How these
okay, so how that works is that the AMIs are provided by AWS has got a set that we provide, but also anybody can provide. So I can go onto my AWS account, create an AMI and share it with the whole world. And anybody can use it if they want to. Yeah, you can do your own one. So there are actually quite a lot of vendors that do this. So Canonical, who are the creators of Ubuntu, actually create the Ubuntu images as well. So you can go look at their account and see the list of all the different Ubuntu images that you can use, and also the latest version. So they bring them out, I think it's once a week or once every 2 weeks with the latest patches. And then you can just use that image and then go from there.
And you get them from the marketplace?
No, you just get them from the normal AMI search list. The marketplace is slightly different. That's if you want to have packaged software where there's potentially an additional cost on it. So a good example is a virtual firewall and intrusion detection service. So there are a couple of vendors that build this. They install it onto an AMI. And then what you do is you go to the marketplace and say, that one, please spin up one of them for me. There's a cost for the hardware that it runs on, along with the licensing cost, but it's then the second billing. Yeah, and then it just gets added to your Amazon bill as well. So it's very easy to spin up these third-party applications if you need them.
So there's multiple ways, basically, to get this AMI.
Yeah, so a couple of ways. Yeah. So
no more to install with CDs.
Oh, luckily not. No. I actually have a pile of CDs on my desk that I still need to work through because I don't know what's on them. I labeled the one with the number 5 and...
Good luck.
Yeah. it made sense at one point. But yeah. So you don't have to worry about that at all. So let's go ahead and we're going to pick Ubuntu. So then the next thing that you have to pick is what size do you want? And that's where it came in terms of that I spoke about earlier. You can pick what you want. So there's a whole list of instance types over here. And especially if you're playing for the first time, the important part here is to keep an eye for this free tier eligible thing over there, because every new AWS account has got a 12-month free tier for most of the services. And there are some services that actually have more than that. And you can just go to, I think it's aws.amazon.com/free. Let me see if I got that right.
I never know. I always Google for that. But this is a good page to bookmark, because you can find what is free for a lot of the services. So
it's actually searchable down here. That's the big thing. Yeah. So you can literally search for whatever service you want or what type of service, and then it'll give you all the details. So exactly. Very, very useful page if you're starting out.
750 hours of EC2.
Yeah, so where that weird number comes from is that because it's per hour billing, 24 hours a day, about 30 days a month, so 24 times 30 gets you to under 750, but I think it's just more than 31 days in terms of so that's where that number comes from.
Nice.
So we're going to use the T2 micro. So that's a single CPU, and it's got 1 gig of memory as well. And just quickly, the T family of instances are slightly different to the other ones, where you've got CPU credits, which is when the instance isn't using the CPU a lot, you build up these credits. And then when you do have something that needs a CPU a lot, then you start using these credits again, because it's called a burstable family type. The idea here is that whatever you run on the T family is not something that needs a CPU the whole time, which means that we can give them to you a lot cheaper, but there is then that CPU credit that you have to take into account. There are different types where you don't have CPU credits if you need that kind of workload, but for us today, this is more than sufficient for what we want to do.
That's good to have in mind, but I think the list of types is so long that if you want to go and learn what they do, go and check it in the AWS website, because I think every reinvent, the list gets longer and longer and longer.
I think the last time I checked, it was more than 185 different types.
Wow. I hope they don't ask for that in the certifications.
No, they don't, luckily. So you just need to know roughly what the instance naming means. So maybe let's quickly cover that. It'll take like a second, which is,
sure.
If you look at the name, T2.micro. So the first one, that letter, is the instance family. So T is for the burstable family. M is for general purpose. C is for compute optimized. And what this means is the balance between the CPU and the RAM and other capabilities. So, for example, the M family, you've got 1:8 ratio between the CPUs and memory. So you get them with 2 CPUs and 16 gigs of RAM. Where, for example, the C family, the ratio is different, and it might be something like 2 CPUs, but with only 4 gigs or 8 gigs of RAM, because they've got higher clock frequencies. So that's the type of family you're dealing with. The second number is the generation. So the higher that number is, the more recent it was released. So higher usually is cheaper and more performant because the CPUs got better. So it's usually pick the latest one as a good option. Then you've got after the full stop, you've got the sizing. So that goes from nano, micro, small, medium, large, extra large, and then it's 2, 4, 6, 8 different multipliers on that. Yeah, it goes up to, I think the largest is 32XL. And it's basically, we call it the t-shirt sizing. So a 2XL is half the size of a 4XL, because it's the same machine. It's just how big of that slice of the machine are you getting effectively.
Wow. Yeah, that's interesting. Yeah. So it makes sense, the naming, that it's not just random letters put together.
No. There's always meaning with them. And then also important here, you'll see the instance store. You will hear something with the difference between the instance storage as well as the EBS volume for it, or rather the instance volume versus the EBS volume. And the difference here is that because it's a VM, it's attached to some physical machine at the bottom. That physical machine might have a hard drive in it. If it does, you'll normally get a slice of that called the instance store, because your VM on the same hardware is using that hard drive over there. Now, let's imagine you shut your VM off and switch it on again, and it spins up over here. That's not the same hard drive. So that's going to be a different hard drive. So if you see instance store and you want to use that hard drive, just remember that it's not going to travel with your VM. Because that's one of the first things people, when you use AWS, you lose data and you're like, but it was there, where to go? Because I rebooted. So to solve that, we've got what we call EBS volumes, which is Elastic Block Store. So normally the AMIs, you would install your operating system on this EBS volume, which is a network attached storage effectively. And then when you shut the VM off and you switch it on again, that then travels with your VM to that new location and then spins up over there.
Nice. So then there is this temporary storage, and then there is this more persistent storage. And in this persistent storage, you can install applications and do all kind of things.
Yeah, you can even, if you want to add multiple of these drives and create a RAID setup with it, where you put the data on multiple different disks to increase speed, or you can do things like that as well should you want to.
It's like using real machines.
At the bottom, there's always a real machine, even with serverless. You just don't know about it.
I know, but I've been so abstracted from it.
Yeah, cool. So next, we're going to head to the actual instance configuration. So this is now where you start hitting a lot of configuration. Yeah. So the first option is hopefully simple, which is asking you how many of these do you want. So do you want a single one, or do you want multiple copies of it? And you'll see there's this option for launching into order scaling groups, which we will get to in one of the future episodes. Don't worry about that right now. Then when you get to the next one, which is the purchasing option, you have to pick between the on-demand or spot instance. Now, the spot instance is, as you can imagine, we've got very large data centers. They're not being utilized 100% all the time, so we've got spare capacity. So what they did is a spot instance makes use of that spare capacity at a price reduction of up to 90% of the normal cost. So you can save 90%, which is a lot. But we might need that capacity. Yes, there's a little but there. We might need that capacity, and if we do need that capacity, we'll send you an API call and let you know that, hey, we need it back, and then you've got 2 minutes to either pause your workload or save the workload or abandon the workload, depending on what your configuration setup is. But to put that in context, on average, over the last 3 months, we've only terminated 5% of all spot instances.
Wow.
So it doesn't happen that often. And if you could look at specific families, you can see that they get very little interruption as well, so under the 5%. So it's, for some workloads, this is perfect.
Is there statistics public about these topics somewhere in the... Oh.
Yes, I can actually show you quickly. It's actually it's one of those fun things I like. If you go back to the EC2 console, and you go down here to spot requests, then at the top here, you'll see there's pricing history. Now let's quickly look for our T2 micro that we had over here, and we look over the last 3 months. So we can see that there wasn't a lot of demand. The price stayed stable at 0.0038 cents compared to the usual 1.26 cents. So it's about a quarter of the price. Yeah, or a third of the price, sorry. So already here's a 66% saving just by using the spot instance. Now, if you pick something like let's say the P3 instances are the ones with that are very big and have GPUs in them for a lot of machine learning, I would expect there to be a little bit of a, so they've also been stable except over here. So there you can see there was a slight little bump over there where the one availability zone became more expensive. So, but in general, when you look at the pricing history, that's usually an indication of how stable it is. If we go to the very large one, here we go. So this is what you can see is what this basically can translate into is that there was a lot of spare capacity, and over this period of time, so just after April 1 until about 16, 17 April-ish or 20, a lot of people started using these instances, so there were no longer any of the full instances available. So that's why it went up to the on-demand price, which means that's now it's the same as on-demand. So we only have on-demand ones available.
Yeah, that's really interesting.
Yeah. So let's go back to our launch wizard over here. So now we know what that single tick box is, which is probably a few hours conversation if you want to.
Yeah, but I think it's good that if you maybe not running anything really client-facing, you can take the risk of going spot instance and it will not get cancelled.
I mean, honestly, before I joined AWS, I used to run my Jenkins masters with spot instances because they never terminated.
Exactly.
It was literally, it could terminate. So the next option over here is the network. So unfortunately, with running EC2 instances, you need to know a little bit about networking, unlike with serverless where you can mostly get away with not knowing.
Scariest part for me, always.
Yeah. So networking on AWS in 2 minutes or less. How it works is you would go create a Amazon VPC, which is a virtual private cloud. So you say, here's a block of IPs where my network's going to be. So it's a virtually defined network. And you give it a CIDR range, which is a classless inter-domain routing address. So something like 172.31.0.0 and then /16. Now what that /16 is, it actually indicates how big the block of IPs is that you get. In the case of a /16, that's 65,000 IPs in there.
Wow.
So we've got this massive chunk of IPs, and then we take that VPC and we slice it into different subnets. So we'll give a subnet with, let's say, 255 IPs or 4,000 IPs with a /24 or a /20, depending. So you split your network into these little subsections called subnets. And each of these subnets you would allocate to an availability zone in terms of to spread the risk when you bring up your instances so they're on different data centers effectively. Because remember, we're building in the cloud, so we are expecting that things will break. So the idea is that you spread, you build for failure the whole time, because at some point something will fail, and it's better to have that built in than to try and quickly scramble to fix it when it does break. Definitely. So what we do is for example, a web server, we would deploy 2 or 3 copies in 2 or 3 availability zones, because if the one goes down, these 2 then stay up again. So you don't have to worry about not having your site available, for example.
Exactly, and that's something. It's always confusing when you're like building serverless is automatically, but when you are building in the more traditional way, you need to really think about it and create all this networking. Is there some tool to design VPCs in an easy way, or something that can help people to visualize this?
Yes, there's a tool called cloudcraft.co that you can use, so cloudcraft.co. And you can use this to go and draw your VPC along with resources. And it actually has an interesting feature where you can spit out a template to use with your infrastructure as code.
So it brings CloudFormation.
Yeah, it does. It outputs CloudFormation last time I checked, yeah.
Nice. So now you know where to find it.
Yeah. So now the good news there is that when you create a new AWS account, we will go create a default VPC for you in each of the regions. That VPC will have some subnets in them that are public site subnets. So just quickly to touch on public and private subnets is that with that network that you've got, what you do is you split it into subnets for resources that are going to be connected directly to the internet. So think of anything that you want from the internet to be able to access that, like a load balancer, or if you're running your own web server, that you would put in a public subnet. And on the other side, for private subnets, it's where you want to put things that aren't going to be accessible from the internet, like a database, or if you've got a web server that's sitting behind a load balancer, that would be in the private subnet over here. So you don't want people to be able to get directly to them. So by default, you've got public subnets inside an account. So everything we do in this 3-part series is going to be in public subnets.
And if we will put a load balancer, then we could create our own VPC. And then...
Yeah. Okay. So you can see over here, we've got one in each availability zone. So I'm just going to go ahead and pick any one. So let's say pick the B1. And you can see at the moment there are 4,089 IPs left in this subnet. There are some resources that are running, that are consuming them. Then the next question over here is, do we want a public IP for this? So an IP that we'll see on the internet. And you'll see that it's by default, it defaults to whatever the subnet value is. In the case of public subnets, you would set this to enabled because you want them to get an IP, because that's why they're in the public subnet, because they want to be accessible from the internet. But you can override this and set it to enabled or disabled. Okay. So in our case, we can see that it's enabled, so we're going to leave it on default for now. Then the placement group is not something we're going to be covering at all. This is just you can actually select the different parts of AWS where you want to run different instances and group them that way, but it's a fairly advanced topic, so let's just skip that for now. For capacity reservation, you can just leave it at the default for open. We're not going to be doing that today. And then for IAM role, this is something that you likely do want to set on your instance, because that's how you give it permission to use other AWS services, like, for example, an S3 bucket where you can store files.
Everything in AWS is created with no permissions. The same happens with Lambda, and the same happens with EC2. If you don't give permissions, they cannot do anything.
Yeah, and I mean that it's a good security practice. You want to give the least amount of privilege, and the least amount is nothing.
Exactly.
So we are going to leave it at none at the moment, because then we can come back when we want to access an S3 bucket from the instance to show. Yeah.
Will this machine, because you said that it will have this external hard drive kind of attached, do we need to give permissions to this machine to access that hard drive, or it comes out of the box?
Oh, no, that's just because it's part of the base configuration of the VM. There's no special permission in this case, luckily.
Okay, good. Just to check, because at least in Lambda, you need to give permissions to whatever you're going to do. So I didn't know here.
No worries. And then next one here is the shutdown behavior. And this is important because when you shut down the image or instance when you're not using it, you can either choose to just stop it. So you can think of it like hibernating and suspending it, and then switch it on later again, or you can set it to automatically terminate, in which case it'll be gone and you have to recreate it again. So by default, it's to stop because, because remember, because you've got that network drive, when you make changes to the operating system, like install, let's say, Engine X, it'll actually install it on the EBS volume, and that stays with that VM and then just shuts down and then comes back up again. So We want to keep it on stop, not on terminate. And then, like I said, certain instances you can hibernate, similar to your laptop, where you close the lid, the power goes off, and you can plug it in somewhere again and it goes on. So it does support that if you want. And then also what we can do is this checkbox means that if you accidentally right-click and say terminate, it'll tell you, sorry, you can't. Please go disable this feature. So it's a nice way to protect your instance from accidental deletions.
Because termination and stop can be very confusing terminology if you don't know what is the difference.
Yeah. So that's basically it on the configuration details. Now the next part is...
And you can do, if you want, everything that we just did as CloudFormation as well.
Yes, you can do everything as CloudFormation. You
or
can
CDK.
Use the AWS. Yeah, I would actually recommend the AWS CDK if you are getting started, because CloudFormation is very verbose, and the CDK abstracts it a little bit away from you. So it's a bit easier to get started with it than with CloudFormation.
That's cool. Maybe we invite you later for CDK and EC2s.
Cool. So now the next section is we need to give our instance some kind of storage. So what you'll see is it starts off with a default 8 gigabyte drive. And what we can do over here is we can increase this. And you can see in here the nice and tell you that 30 gigs are free under the normal free tier. Yeah. So you can take it up to 30 gigs if you want to. I mean, we're not really going to do anything, so I'll leave it at 8 for now. Typically with Ubuntu, with 8, you end up with about 4.6, 4.3 gigs of space left on the drive after the operating system and everything else is running there.
Nice. And this is the external hard drive that you will keep all your...
Yes. Yeah, so it's that network hard drive
Nice.
effectively. Then speaking of the network hard drive, you have to pick what one do you want. So you can choose between 3 of them. You've got the magnetic one, which is the old... We call them spinning rust as a joke because they are iron oxide, but it's a physical old hard drive that spins with the platters.
It's slow.
So they're slow, but they are cheaper. So if you want something cheap and not fast, you can do this. Or you can use the SSDs. And with SSDs, you've got a choice between the GP2, which is general purpose, or the provisioned IOPS. And the difference here is that with provisioned IOPS, you say, I want a specific performance on the drive, like a certain amount of operations per second. No matter when. So you pay a bit more for that because you are specifying a high performance drive. Where with general purpose, it's similar to the T family where you build up credits to be able to burst for performance. So you can burst up to, I think, 3,000 IOPS above whatever you pick here when you have got those credits available. So that's just, once again, it's that trade-off between excess capacity and only having it for certain times, but getting a big discount again.
Yeah, and it depends on what you need. I think in general, with the basic one, it's more than enough.
Yeah, no, the GP2 is more than enough, and it's also part of the free tier, so definitely go for GP2 here. And over here, you can see that you get the IOPS. And just quickly to show you, the IOPS are dependent on the size of drive you pick when you go for the GP2 version. So if I, for example, picked a 500 gig one over here, you'll see that jumps to 1,500 because of the drive size.
So the IOPS is the amount of times that you can write on the disk, basically.
Per second. It's not quite throughput per second, but it's how many interactions per second can you make with the drive. Yeah. So obviously the larger the drive is, the more we expect you to do, so that's why we give you more performance on it. But for our case, 8 is more than enough, And then what you can see over here is that, once again, this is do you want me to delete this drive when you terminate the instance? This is selected by default on, because if you've made the decision, I want to get rid of this server, you probably want to get rid of the operating system installed on it as well. Yeah, but you can untick this, in which case you need to remember to go delete this EBS volume, or you can attach it somewhere else. Depends on what you want to do.
What you have in the disk, because maybe if you have the operating system, you don't care, but if you have real data, that is something that you want to move around. That's different. Yeah,
so an example there is, let's say you want real data and it's something you want to save, you can just add another volume over here. Decide the size, the type, and again, you can do this for the amount of drives that you need. But we only need one for today, so we're going to leave it at the D. Cool. So now, next one, tags. So you can give your instance multiple tags. The default one you probably want to give it is the name tag. So you want to call it something like EC2 demo. And what is super fun over here that you can actually do, that I always do, is you can actually see it's in my history over here, is you can grab emojis. Because it will display it with emojis inside the console. So you can do this. It's super fun. I used to use the little pan with the egg in it for my chef server. So
I never thought about putting emojis in tags. Now I will change that and add emojis in tags.
So just a warning here, people who use the CLI a lot will not be happy with you because they then have to go copy and paste them because it's with Unicode is actually a series of, I think, 4 or 5 text characters to represent it. It's not easy to type, but it is fun for the console. Next, we are going to create a security group. So the security group is the firewall around your instance. But because we're doing a virtual network, we also do virtual firewall. So the firewall isn't running on the operating system like you used to. You can still install one if you want to, but it's better to configure it inside the account using the security group because you can now take this firewall and put it around multiple of these instances. So let's say I want to create a firewall with only port 80 open for a web server. I can create one security group and attach it to many instances, and they all will then only have port 80 open. So it's a nice way to handle that kind of security.
So you can reutilize the same security group you created now, and then if you create a new EC2 instance in the same VPC, you can put exactly the same security group, and when you change the security group, everything will change.
Yes. And the other nice thing with this is, so we're just going to call it FooBar EC2 over here, is you can see that it's configured to allow SSH from all IPs on the internet. So this 0000/0 is the notation to allow every single IP. So once we launch this, anybody will be able to SSH to it. Luckily, we're doing this recording in advance, so I will delete this instance so nobody will be able to SSH to it anymore.
Don't forget.
But as you can see, there's a nice big warning over here that says, watch out for this. Yeah.
It's like a public bucket.
Not as bad, because luckily SSH, you need to have the key to be able to get in. So the public bucket, it's like
just with the URL.
Shop with no. Yeah. Cool. So now we have got our EC2 instance over here. So now we go on to the review. And this is where we can see all of the details that we just picked. So you can see you're going to get a warning up here again with the security saying, hey, are you sure? Because we're opening it up to the entire world. Are you sure you want to do this? Like I said, with SSH, that is luckily not too big of a concern because SSH is a secure protocol. And the way the instance is configured is you have to use an SSH key. You can't use a username and password. So unless you've got that key, which you can only get from inside this account, you can't get to the server. Now we can see all the details of everything that we configured over here. And now we're going to go ahead and launch it. Except it wants us to know, make sure that we've got the SSH key because like I just said, you can't get in without it. So I'm going to pick one that I already have, which is this specific webinar one. And we even force you to acknowledge that you have it because if you spin it up and you don't have it, you literally cannot get into this instance. There's no way to get into it again. So we're going to do that. So now we're going to go ahead and launch this instance. Now, this normally, if I go over here, it takes about between 21 and about 31 seconds to launch this one in this specific region, which is Ireland. I just did this quite a few times in the last week, so that's why I know that number off by heart. But it's fairly quick. Sometimes it might take like a minute or so, but it's generally for the Linux instances very, very quick. And you can see at the moment it shows us that it's in the pending state. And there is the public IP. So I'm going to go ahead and grab that public IP so long. And let me just refresh because it might actually it's already running. Ooh. So I should already be able to SSH to it. So I'm going to use that key that we have, which is the webinar.pem file. And then I'm going to SSH in as the Ubuntu user because I'm using Ubuntu, so I know that it's pre-configured with the Ubuntu user. If you, for example, use the Amazon Linux, it's the EC2 user. Each operating system has got its own user, so just go look at the documentation about what the name is.
And when you're using, one question, when you're using Cloud9 as you're using now, is the SSH key configured automatically or you need to configure it in there before starting?
You would need to copy it. So what Cloud9 is an online IDE like you can see, but if you go to the console over here, and let me just remove this filter over here, that's actually where we are running at the moment. So it literally is just a web interface connected to that EC2 instance that you spin up, and you then would have to copy your key onto this machine, which I've done before.
So you need to do it as it was your own local machine as well.
Yeah. Okay. So this is your own little private IDE to play around with, effectively. Now we are going to SSH to that machine, and we can say yes. And you'll see that we are now logged in. And I'm just quickly going to clear the screen, and now you can do whatever you want. So, for example, if I say uname-v, I can see that I'm running Ubuntu. So I can use the -a to get the specific instance. So I can see we're running the Linux kernel 4.15.0 AWS.
That's when we recorded it. No, it's wrong, the date.
No, it's on UTC.
But it says 26th of March.
Wait.
Oh, now it says the right day.
Oh, No. So that is when the kernel was compiled.
Ah, okay. I was like, why is it
Yes. Sorry, I also forgot about that part. Yeah.
Yeah, that's
So
funny.
yeah.
Now we
Well,
know.
it's a good indication.
Yeah.
You know the info, but you don't always remember that you know the info. So.
Good.
And what you can also do is you can look for example, in proc CPU if you want to get the CPU info. So as you would with a normal server. So at this point in time, there's a server running in one of our availability zones and data centers. And from your perspective, you just SSH into it as if it was a physical server. And now you can start installing your software and configuring it any way you want.
Wow.
So you can see we're actually running on Xeon E5 2676 version 3 CPUs at 2.4 gigahertz.
Nice.
Yeah. So now you've got a virtual server. Now
Woohoo.
it depends entirely on what it is you want to do.
Exactly.
So yeah, usually what we want to do is we want to run some kind of application, and some kind of application usually needs to be able to store some kind of data, which is where a database comes in. So why don't we go create a database quickly? So one nice tip here is you might have seen these shortcuts up here. What you can do is you see this little tick or pin over here. You click on it, and then you can drag things in and out here. So you can see I did some code build stuff over there. So now I want to add, for example, RDS. I can just take it, and I can drag it up there. Click, and now I've got that shortcut available the whole time.
Good. So
it makes it.
We can go to RDS. That is another service I never took up.
Cool. So Amazon RDS stands for Relational Database Service. So this is where you spin up a relational database, and that can be one of many flavors. So let me show you how easy that is. And funnily enough, it's easier to spin up a database cluster across multiple availability zones that has automatic backups and patching and everything configured than it was that EC2 instance in terms of all the config options we just had to pick. It's very easy. So we're going to say, let's create a database. And the first thing it's going to do is
nice.
Yeah. Now it asks us what type do we want to create. So we can pick Amazon Aurora, which is Amazon's custom-built internet scale relational database. So it can connect using either MySQL or Postgres drivers. So from an application perspective, it looks like it's MySQL or Postgres, depending on which one you pick. But under the hood, it's actually completely different.
Yeah.
We've actually split the compute and the storage, but that's a long discussion. But from your perspective, I recommend Aurora because it's less maintenance.
Yeah.
Because, for example, the disk grows automatically for you. You don't have to constantly grow it as your data increases.
It's built for the cloud. So I will link in the description box. I think there is a really good Rainband talk. I don't know if it's from this year or last year that talks about the Aurora and how it's built. So I will try to find that talk because it was very interesting to see how they designed the whole thing.
No, it's good. But I mean, I think the summary there is that it's built for the internet and also it's cheaper for the performance you get.
Yeah.
So not a bad choice. Yeah.
No.
And also, just quickly, it doesn't lock you in because it uses MySQL and Postgres. You can use pgdump or MySQL dump to extract your data and take it elsewhere. We don't want to lock you into database specifics. So you cancel move.
Yeah. And you can migrate your own database to Aurora quite easy with the migration tools. So if you have a Postgres database and you want to migrate to Aurora, the database migration service will help you for that. So
cool. So then what we do is, like I said, with Aurora, you have to pick between MySQL and Postgres. And then you have to pick the version that you want. So you can see there's a whole list of versions over here. And this is going to be a little bit too much for today, but with Aurora comes a whole lot of interesting capabilities. So when you think of the database and you're spinning it up in a single region, let's say you've got one copy over here, then obviously only things inside that region can speak to that database. Now, if that database falls over, it's gone, your data is gone, and you can no longer keep your app up and running. So you normally cluster it by having two of these in a cluster mode where there's a primary and a 1 or up to 15 secondaries, where the read nodes, as we call them. And then what can happen is you can configure so it automatically falls over to the other ones when that primary, something happens to it. Or if you, for example, patching, because how it works is that you can patch the read-only to a later version, then fail over to that one, patch the old primary, and then you've upgraded your cluster without downtime.
Now I remember why I picked the serverless. I'm so not up to this.
Yes. So it's gonna become a little bit more fun now. So what you can see over here, if you look on the right, is that firstly, if you want one writer and multiple read nodes, you need to pick these specific versions as listed here.
Wow.
You could also go a bit more fancy and say you've got more than one instance that can accept writes, because by default you only have one node that is connected to do any kind of write, and then from there it replicates elsewhere. But you can have more than one node if you want to do a higher level of traffic in terms of for the writing. And you can even have that writer in some of the other regions as well with some of the configuration setups. Then also you can do something interesting, which is a single writer using parallel queries. So when you do a select, it can actually split up that query and process it bit by bit on all the different readers to actually spread the load and bring you back the result faster.
That's super performant.
Yes, very performant. So that's also a specific version that you have to pick in terms of the version drop down here. And then the one you probably like is the serverless version, which we'll be using today. It's not quite serverless. It's serverless in the sense that from your perspective, you don't have to worry about the configuration.
Yeah.
You tell it, I want an instance, and you give it the minimum and the maximum it can scale to. And depending on how many requests you send to the database, it will either scale up or down the capacity in terms of the CPU and the RAM that it's connected to your storage for that.
Yeah.
And you can even scale it down to 0. This is actually what we use internally for our reporting, where during the day, you don't often access our reports, so the database is switched off to 0. And then when someone does the report query, it comes up, takes about 30 seconds to come up, and then we can get our data out of the report database.
Exactly. And that's the nice thing. You don't need to waste CPU and resources when nobody's using it.
Yeah, definitely. And then the last one is global databases. We actually have the database spanning multiple regions. And this is if you want to have your app running, let's say, in both US East 1 and EU West 1, like the region we are currently in.
And this will do all the automatic backups and migration of data and replication.
Well, replication, not migration, because you're running
replication.
So you're running nodes in multiple locations. So how it works is there's one primary node, which will, let's say, be in US East 1, and then you can have read nodes in other regions as well. And then what happens is, let's say that region goes off where the writer is, it'll pick one of the other ones based on the priority to become the main writer node again. And then if you use the DNS, which we'll show you how, it'll automatically change it to point to that new one. So there's no work for you to do to point to the new one when there was some kind of failure.
Nice. And this is only possible in Aurora. Basically, the other ones don't have all this.
No, it's the other ones because of the way Aurora was built under the hood. Allows us to do this.
This is really powerful, all these features.
I know it is. It's really, really useful. So, like I said, we're going to go for regional, and we are going to pick serverless because I want to show you how it can scale up and down easily. Then we're going to give it some kind of name. So we're going to call it FooBar because we're on the FooBar channel. And then, as with most databases, you have to give it some kind of username and password. I'm going to give it something super secret that I won't share with Marcia even, so she can't get into the database. You can always select auto-generate, and what that'll do is it'll generate a random secure password for you. Then capacity. Now, this is where the scaling comes around. So you can see here, you've got a minimum and a maximum, and minimum is 1 CPU and 2 gigs of RAM, but you can go all the way up to 250, and 488 gigs of RAM. So that's quite a chunky database.
Maybe we don't need that today.
No, we don't need that. But remember, it'll only scale up if there's enough capacity on it to want to scale up. But what you can do here is just select something smaller that you know it won't, for example, if something does go wrong, scale up to a crazy level and create a massive bill for you. On that, for beginners, if you do have a situation where you did something accidentally in the console and you ran something that was very expensive and you didn't intend to, submit a support ticket, ask them and explain to them what happened, because our support will help you out there. They usually credit people for mistakes like that. Obviously, if you are abusing the system, they're going to say, no, we saw you were mining Bitcoin. Sorry, we're not going to give you money. But if it was an honest mistake, they're very friendly. So please always ask them.
That's very important to let people know, because a lot of people are afraid of trying new things just because they will go into costs or crazy costs. But don't worry, support is there to help you.
Yeah, they're very friendly.
Yeah.
And then, like I said before, unfortunately, you need to know a little bit about networking. So once again, we are going to pick the default VPC over here. And for today, we're just going to ignore all the other configuration settings over here and create it as is. And then we're going to see what things we run into when we create it. So like I said, this is actually a lot less work than setting up the instance, it seems, because there's a lot less options for you.
Yeah, I think because it has already built with a lot of opinions, so you don't need to worry about it. And that's a nice thing of this managed service in general, that you don't need to manage the instance that is running this database or worry too much about it. There is a lot of work done by AWS. So
yeah, no, that's the whole point here is that, because a nice example here that I usually use in my talks is that, let's say you go out and you buy a car. Are you going to go to the company because they've got mail servers that work? You know, they can send a mail and receive a mail. It's like, Probably if they don't receive a mail, you're not going to use them. But let's say they get it faster than the other company. You don't really care how quickly they get the mail, or just that it works. So similar, you want the database to just work, and you want to go build features. You don't want to spend weeks and weeks setting it up, backing it up, configuring it, and all that, because you could rather be building a feature that gets people to use your app.
Exactly, building value for your own customers.
We've now paused and we're back, and it took actually only about 2 minutes to spin up. So this is now our database. So let's take a quick look at it. Now, what you can see is that it has got the info says it's available. We're using the Aurora MySQL engine. We can see that it's in the region in AZ is EU West 1, and it currently has got 4 capacity units allocated to it.
What is a capacity unit in Aurora?
So that was that drop down that I showed you when we created it. One capacity unit equals 1 CPU and 2 RAM.
True.
Oh, sorry, 2 gigs of RAM. Yeah.
Good.
Which means that,
in Dynamo, it's a totally different story, capacity units. So it's good to clarify again.
So luckily, it's easy in RDS to understand.
Yeah.
And then what we have down here is all the different configurations for the actual instance. So the important one for us is this endpoint. So this is what we'll use to actually access this database. So if we take that endpoint and we go back to our EC2 instance over here, what I can do is I can, for example, ping that, and it'll send back a private IP to me. It won't respond to the ping because there's a security group around it. And and this is where the next part for this video will be, where it's, if we go, we try to telnet, which is a utility that allows you to connect or open up a port to another server and then start sending requests to it. And we put this in, and we say that on port 3306, which is the default for MySQL, if we try and connect to it, you'll see that it just hangs over here. And the reason is that that RDS instance has got its own security group around it, and we didn't give our EC2 instance permission to access it. So we need to go fix that thing. So let's go to the RDS console, and over here we can go to the, you can see over here in security, it's got the VPC security group. So let's quickly go open that one up, and you can see that it is the default one. So because we didn't specify one, it grabbed the default security group that's created inside the VPC that we provide for you. What we can see over here is the security group configured for that the RDS instance is using. And what we can see is this security group has got one inbound rule that says it allows all traffic on all protocols and on all ports from the security group itself. So this is a very interesting attribute from security groups, and why you want to use them instead of IPs, because when I create a security group, I can give one security group access to another security group. And what we're saying over here is that anything inside the security group is allowed to talk to anything else inside the group, but nothing from outside can actually speak into it. And that's why we can't access them. So now what we have to do is they call it punching a hole in the security group. So we say edit inbound rules, and then we're going to add a rule. So in our case, we know that it's a TCP connection, and it's going to be on port 3306. And then in terms of the source, now usually with old firewalls, you would have to provide an IP range over here. But when you spin up an EC2 instance, it automatically gets an IP in the subnet, so you don't necessarily know what it's going to be, or you might move that instance around. So instead of worrying about the IP, we use the security group. So if I go here, FooBar, you'll see that this is the security group we created. So I can just say FooBar. So any instance, regardless of what the IP is, with that security group, if it's inside this VPC, can then access our database.
Wow, cool.
Yeah. So now we go ahead and we say save rule, and you can say it's saved. And now if we go back to our instance over here, and I'm going to just run the command again. Now what we can see is it says MySQL native password. So obviously this isn't normally how you would connect to a database, but now we have a connection. So if we had an application over here, it can now speak to the database.
Cool, that's so nice. And that was quite simple to connect the two things together.
Yeah, because everything is taken care of with the security group and the DNS entry for you.
So I think this kind of wraps the first episode on what we wanted to talk today about creating an EC2, learning a little bit about it. I think we learned quite a lot about security groups. We learned about RDS and Aurora. And in the next episode, we will talk a little bit more about security and permissions and going more in depth in that bit. Thank you very much, Cobus, for your time. And we'll see you in a couple of weeks talking about more of this stuff that is totally new for me.
Awesome. I hope it was fun for you at least.
Oh, I learned so much. And I think this is a great chance for me to learn things that I will be too lazy to just go and read. So it's great. I can entertain you and at the same time learn. So yay.
So
So thank you very much. This was the video for today. If you want me to teach you something else for the certification, let me know in the comments box below. If you want to know what my progress is, how I'm doing, and things like that, also let me know in the comment box below. It's been a rough journey because I thought I would be not busy for work, but work has been very busy. But I can chat about that, how I'm organizing my time, how I'm doing, and maybe it helps you out. I don't know, but let me know. There will be another episode coming in 2 weeks from now, so stay tuned for that if you want to know how this story continues. And don't forget, give a thumbs up so YouTube recommend this video to others. And I see you in the next episode of FooBar. Ciao, ciao!